UML class diagrams. What are they? UML, Unified Modeling Language. Alright, so when it comes to designing a class, we use this thing called UML to draw the classes, and it's a pretty straightforward process. Okay, so a class diagram is a rectangle that has 3 sections to it. That's it. 3 simple sections. Nothing rocket sciencey, nothing. Okay, just that. We've got the top section, which contains the class name. So the top section in this case is here, the class name. We've got, after that, let's try it now, it keeps moving, the middle section. Now this contains the attributes and the names and the data types. So that one is there, okay? And then after that, we've got the bottom section, and this bottom section contains the methods. And this is, for lack of a better way to describe it, our template. So this is the template that's used for designing a class in a class diagram, okay? We have the name, we have the class fields, and the methods. That's it. So here is our car class in a UML diagram, and there's a bit going on there, all right? Now, it's not a complete class diagram. You need to understand that, all right? But we've got up in this section here are all of our class fields. So we've got a make, which is of data type string. We've got a fuel level, which is of data type double. Then in the bottom section, what we've got are our methods. And we've got our change speed method, which the change speed method is a void method. We've got the change fuel level method, okay, which is also of type void, meaning there's no return value from it. So we're jumping now into inheritance when it comes to the class diagram. So how does it work? Right at the top here, we have our person, okay? Now our person has a name, which is of a string, and has 2 methods, the getName and the setName methods. Then we have an employee, which if you recall is a type of person. It inherits from person, and we can see that here with that arrow. And now we add to it staff ID, okay? And then we go again with our manager class, okay? So our employee has a name because up here we had name. Our manager has a staff ID because up here. So all of the values, all of the class fields, if you like, and all of the methods that were in there were down into here. And then everything that was in here is also available down in here, okay? So we have inherited from, I should say manager has inherited from employee, who has inherited from person. Let's take a look at classes in pseudocode. We've got our person with the following attributes: a first name, a family name, day of birth, month of birth, and a year of birth. Okay, that's enough for now. Here is our UML diagram, and it's pretty full if we look at it. Okay, so you can see all of these class fields. Now, we have these things here, and these things here. These are the methods, or some of the methods that are available. And what you'll notice is we've got set, 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 and get, 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 get. So these are our setters, and these are our getters. And we're going to talk a little bit more in a moment about setters and getters, okay? And what you'll see is there is a setter and a getter for each class field. So, how do we go about constructing it? So we've said class person, and I've said class fields, and there we have the name or the class fields listed. Pretty straightforward when it comes to class fields in pseudocode. Inheritance, all right? Class employee class field, and I've said inherits from person and staff ID and string. Now, you could, I'm quite content because there is no right or wrong way in one sense. It's not quite, cluck. Keep cluck in mind. If you wanted to say, put this up there, inherits from person, that's fine. And then you've covered those things all off very nicely, okay? Now we want to look at accessors and mutators. Okay, accessors are our getters. Mutators are our setters. So when it comes to working with instance variables, as you can imagine, the values within instance variables needs to be able to change, okay? So it evolves and we need to change it. We also need to be able to retrieve the values so we can use that data for things. Makes sense, I would think. Okay, so our accessors, which are our getters, and our mutators are the setters. These are the things within our class that allow us to do this with our class fields instance variables. So our accessor methods, also known as getters, okay? Now, they get information, they retrieve information from the object, all right? Now, when it comes to this, we need to clearly define that what are they retrieving. So when we've defined our data types, we then know, so what do I mean by defined our data types? Our class field has a defined data type. So our accessor will return that data type. Why? Because it's retrieving from that class field the value that's there and returning it to whatever has called that method. So we say each accessor, okay, it retrieves a single class field's value. That's it. Straightforward. So here is one of the accessors. Whoops, bit of creaking on the chair. In pseudocode, get first name. It doesn't have any imports. It has an export, which is the first name, and it's a string. Return the first name value, it should say there. And one of the things is we say export copy of first name or return copy of first name. I don't mind. Either or is perfectly fine. It just needs to be clear, logical, understandable, consistent, and correct. Now, as I've said, each class field, each instance variable has an accessor. And our get last name, get date of birth, get birth month, get birth year are all done in a similar manner. Now let's have a look at some mutator methods, the setters, all right? Now, this is used to send information into the object. That's when we want to modify the instance variable or the class field value, okay? Now, this new information is going to change the value within the class field. So we say it mutates the object's state. Because if you think back to when we were talking about state, it's those values in our variables, in the instance variables, that define the state. So we're going to change the state of our object. And again, we need to have clearly defined data types because, for instance, name is of type string, so we can send into it, name David. All right, we send in something of type string. Now, there's usually a mutator method for each class field, okay? Let's have a look at mutators and import validation, because it's important that the imported value is validated to ensure it is the correct type. Okay, so we need to make sure that when we update something, we're updating it with a valid input, if you like. Otherwise, our object moves into a state which it's not meant to be in, an invalid state. So, looking at what I'm saying here is when we're putting data in, we check to make sure something that is invalid is not used. The mutation, when it's invalid data, should not be permitted. We can throw an exception, okay, or we can inform the user. So let's have a look at importing and validation, okay? When we know we've validated it, what it does, if you like, it gives the trust in the software system that the state is in the object is in a valid state, okay? Now, sometimes validation is simply not possible. All right, when would it not be possible? Well, a person's name. It's not possible to validate a person's name. Okay, the title of a book. We can't validate the book title. All right. Now, what we do in these cases is we generally check for null strings, and if we've got null strings, we can do something such as put in a default value. So validation. Okay, really important. Every piece of data needs to be validated, all right, to ensure it is the value, okay, so we may not be checking to know if it's 10 or 20, though we may be, okay. We want to make sure that we've got the right data going in, okay. When it comes to validating dates, okay, when is a date valid? These are really important. Dates is one of the best things to practice validation on, okay? And when we do validation, that may mean we have to create more methods within our class to actually execute the validation checks. So here's a mutator method, okay? Set first name, it imports the parameter first name, doesn't export anything, state of the first name is updated, okay, first name is assigned P first name. Straightforward. And as with getters, the set family name, all of the other things, set family, do we say family name? Or have I made a mistake here and is it last name? See? We spot errors as we go along and we can make the changes. So we set these things. Now, validation in this setting where it comes to these kinds of things, can you see where validation may need to occur? I've got this one here, this validation. Okay, so what I've done is I've created a rectangle class, okay, and the side length and the height are side height, side length, our two variables, and we need to validate them to ensure something. So if we have a look at this, what are we doing? We're importing the side length, which is of type double. And then in our algorithm, we're checking, because if you have a rectangle, this here cannot be negative, and nor can that. So if you ask what's the side length and you say -2, that doesn't work. So we perform a validation. And in this case, I haven't thrown an exception. I've just put out a error message, okay? So the last couple of things, the state of two-person objects. In this case, what we've got is the state of this object is we're looking at Muhammad Salah 15/6/1992. So the state of this object is defined, if you like, through the values that are in the instance variables. And object person 2, their state is defined by the same things. All right? Those things, the values in those variables define our state of the object.